I hope you still have some energy left before the party, but I guess that's always a motivator to still stick around. So let's see what we can do about scaling and auditing events. So oftentimes, especially around security or in our applications, we have something like this where we say, this is kind of fine, right? Until you have some security incident, and those generally come in 3 different groups. Like they're the for your information group, the what the fuck group, and the oh my god group. And those are normally the 3 kinds of categories that you can have around security events. And then you always hope that you're not in the oh my god group, because then everything is really on fire. And that's when you normally learn that something bad happened from the press. Like if there is a news article about you got hacked or some of your users complained badly, that's normally this oh my god group. And then sometimes you have that what the fuck group when an attacker is, for example, asking for ransomware money, or maybe if somebody is mining bitcoins on your cloud provider and suddenly you have a very large bill. That's still not very good. Ideally, you find out yourself, and ideally you find out before something bad happens and you can actually prove that nothing bad happened. And we want to dive a bit into the auditing part of that we can prove that nothing bad happened, basically. So that's the idea. Obviously, like anywhere else, there is no single solution or silver bullet. So there is not one tool that you buy and install and you're done. I know that sometimes vendors sell those, and you can totally sell them, you just cannot buy them normally because there is no tool that does everything for you. So we want to start off with Auditd on Linux. Who has heard or used Auditd before? Okay, looks like I can tell most of you something new. So Auditd is something, this is from the man page. It's a user-space component of the Linux auditing framework, and it basically checks for specific conditions if they have been met, and then you will log an event. And then you can use some Linux tools to actually check out what has happened on your system. And they can check processes, they can check network interactions, they can check what user has run, what specific command, and they just collect all of these pieces of information. What the general structure in those looks like is you have your application and your application does something, and then it passes, the calls pass through the kernel, and the kernel basically checks, is it a specific user, what is the task doing, and what is the exit code? And if any one of those passes through the exclude filter in Auditd that you have defined, then you will log the event. So basically what this is doing, you define a rule and say like this should be logged, and then it will pass through the filter and then it will be collected. And that's how you figure out what has happened. So for example, if you know nobody should start a specific binary or a specific user group shouldn't access some file, you could watch out for that, and as soon as it happens, you log it, and then after the fact, you can say like, hey, I see somebody broke in and ran this binary that nobody should have been running, or something weird happened there. And then you can prove what good or bad thing happened in your system. So just to give you a quick idea of how that looks like, and I'll try not to drop my coffee here. So let me make this a little larger. So my host where I'm running this is Xera WTF, because WTF is always the right domain for any server. What? We'll start this fresh. So, and then you can run, for example, our report. That is the auditing report, and that would tell you that something ran here and you see 17 people tried to log in and you have 3 users in your system. This is just an overview. What you basically get this report from is you have sudo ausearch, and then you can just say, I want the raw events. And then you will have a lot of events scrolling by. These are basically the independent events that are building up that report from the previous screen. And for example, here you can see every line here has a type. So for example, here a daemon ended, the Auditd daemon was stopped here, and we basically terminated that one, and the operation was successful. And then you could filter down successful or unsuccessful events. And these are all the raw events that Auditd has collected for my user. If you want to get a better understanding of what all of those mean, Red Hat has a pretty good documentation for those, and it can walk you through what all of those are doing. For example, here they have this example here with a system call, and then they walk you through the different parameters of what all of those are and do. I don't want to read the man page to you or the documentation from Red Hat because you can do that yourself. I have linked it in the slide so you can figure out what all the individual pieces are from here. If you want to have more rules, because rules definitions are always kind of tricky, in the GitHub repository of Auditd, you can actually find more of these rules. So if I switch over here, this is the user space component, and here you can see a lot of rules that have been defined. So for example, power abuse would be you have a root user that reads the home directory of another non-root user. So since you have sudo privileges, you could just run some random commands against the user and could read their files, which is probably not something you should be doing. And to collect that, this is the rule how to do it. And basically what you're doing is you define always when the program exits and somebody accesses the home directory, and that user ID is 0, so you have a root user, and they access something from a home directory from a user group that is greater than 1,000, so a non-root user, then you basically want to log this, and you can actually check for that with a key power abuse. And that will be logged. And that would then generate an Auditd message. It's a kind of arcane syntax to write those checks, and I always need to check the documentation how to figure out what to do. But at some point you probably get used to writing checks like this one here. So this is the general idea of Auditd. If you want to see some actual rules that people have developed and deployed on their systems, there is one repository that I've linked here that actually defines some of the more widely used rules. For example, here it defines what to do and how to, like why. For example, monitoring all the network connections. And yes, this will be noisy, but this will, for example, collect all the open sockets that you have. And every time you open something, you could monitor that. And after the fact, when somebody opens, I don't know, a remote shell to your server, you know, okay, this was the specific user that opened something on this port, and you would have at least logged the information. And you could have a lot of other rules of what to do when somebody modifies a specific file or runs a binary or whatever. All of those are common rules that you can activate, and then you can log those. Okay. One thing that is still a bit work in progress in Auditd are namespaces. So if you use anything around containers, you might not be able to attribute that correctly to the specific container where this is running. This is a meta issue, and it has a lot of subpoints, so it might still take some time until that is fully done. So you want to log and collect all the things, because you saw the ausearch raw where you had all the individual log lines. This is nice, but it sits on one server. What happens if you have like 100 servers? You won't SSH into 100 servers to see what's going on them. So what do you want to do with those logs then? Probably you want to centralize them. So you want to kind of collect them. How do you centralize stuff, especially around logging? Yeah, since I'm working for this company, we have like a widely used logging solution. So Elastic, if you have never heard of us, we're doing Elasticsearch, Logstash, Kibana, Beats. I mostly travel around to show kind of the things that we have and do. Maybe, yeah, this is what I generally do. I build highly monitored Hello World applications, and today is no exception. So this is just a Hello World of what you can monitor, and I can show you some samples as we go along. Who is using this already? Okay, a couple. Okay, quite a few. Very good. So maybe for those of you who have never seen that, Elasticsearch is the thing that stores the data, Kibana can visualize, and Logstash is the thing that gets the data and parses or enriches it. What do I mean when I say parse? So you have a log line, like this one here, and it has a lot of good information in it. So for example, you know which type of event it was. You have a timestamp in here, you know that an operation was terminated, so you probably would write a regular expression to actually parse this and then extract the pieces of information. Who likes to write regular expressions? That's kind of a trick question, right? I always say this is a bit like the Stockholm syndrome, where you get so used to writing regular expressions that at some point you just accept this is the only proper way to do it. Or it might also be job security, because regular expressions are a bit like Perl. You can maybe write them, but nobody else can read your rules. So nobody will be able to fire you once you have written all these grok patterns, because nobody else will be able to figure out what is going on. But enough making fun of those. We added another component later on called beats, which is like a lightweight agent or shipper. It's written in Go, so you get native binaries. You don't need to put the JVM everywhere. The main problem is there is no B in elk. So what did we do? We tried this one here, the elk B or belk. You can see it looks like something like this. You see it's a B and it's an elk. It's a perfect combination of things. The bad thing in this is, what happens if we add another component? We'll get another letter, and it will get very hard to make up the next animal. So we kind of just call it elastic stack now, because in terms of naming, this is very scalable, and it probably, or the stack looks something like this. So you have your agent or shipper that can forward data either to Logstash or to Elasticsearch directly, that stores everything, and Kibana can visualize. And then you can take all these logging events and work with them. So we created a module, the so-called Auditd FILEBEAT module, because this is a log file. So FILEBEAT is basically tailing the file and forwarding it, and then we try to parse it. Just take a guess. How much fun will it be to parse these Auditd messages? Not much fun, because every line is different. Because depending, a user login event has different things back here than a user start or a daemon end. So you write a lot of very complicated regular expressions. And it kind of works, but it's no fun. But we did the work. So if you've never seen Kibana, this is Kibana. Let me show what you can get out of these events once we have parsed those. So what I have done basically is I started FILEBEAT and say like, watch the auditing information, and it will automatically collect it, forward it, parse it, and then you even can put it in a dashboard. So FILEBEAT audit. Those are the auditing events that we are interested in. And let me switch the time frame to the last 7 days, because that's when I ran Auditd. And you can see, for example, here, this was when I ran Auditd, because I switched it to something else. Let me zoom into that time frame here. And you can see, for example, these were spikes when things were happening. You can see which users were most interacting with running some Auditd or some commands. For example, you can see there was some user David or Belinda or whatever. You can also see where the requests are coming from. And it's kind of interesting, because this time it was the Middle East. Oftentimes we see the most requests either coming from Russia or China, when somebody tries to SSH into your instances, and then you would have auditing events from those. But this time it seems to be the Middle East that was most active. And you can see these are all the different things that people tried out. So for example, SSH logins seem to be the #1 group of auditing events that we have collected over time, because a lot of SSH brute forcing is happening. And you could find the individual events down here. By the way, you could also switch over to a dedicated SSH dashboard. And we'll get back to that information a bit later on. But just to give you an idea, let's say the last 7 days in SSH login attempts. And you can see, well, let's say the last 24 hours maybe. This is not what I wanted. Let's say the last 24 hours. And then you have a rough idea how many people are trying to connect to your instance. And this is one single server. And you can see in one 30-minute time slot, I have like 100 failed login attempts here. And you could see this was me when I was successful. And then you could also see like which users are popular, for example, or which regions. What's kind of cool is you could just say, I want to have just the logins from China. This is the one I want. So I just draw around China here, very badly. And then it would automatically filter down that entire search panel here just to China, and then you could see which requests from China are kind of popular. And there are still kind of a lot, and I'm always surprised what people are trying here. Okay, so this was Auditd, and this works all fine. But we're always trying to kind of like dog food what we're building. Or the French would always say, drink your own champagne because it sounds much nicer than eating your own dog food. Because they don't seem to like dog food. And we have this cloud service where we run for a lot of customers' data. And since we have data, it's kind of interesting that somebody might try to break in. And we wanted to run Auditd for that, but it was such a pain in the ass to parse all those log lines. So what we did was we created a new beat called auditbeat, which rather than the system writing out to that log line and then trying to parse the log line, we would take the raw log event from the system directly without writing it to a file and forwarding it directly. So we skip the parsing, which is generally a smart idea if you can. And it can correlate events, it can give UIDs to users, and it can directly forward to Elasticsearch, which makes your life a lot easier afterwards. It also supports, for example, a lot of the features that eBPF that you only get on newer kernels support. So it's not using eBPF, but it's using Auditd, but you get a lot of those powers. And well, it's written in Golang. Basically, it also supports Docker. So we know exactly from which namespace a call is coming from. So even if you run everything in containers or Kubernetes, we would know which events are happening in which specific container. It is all built on a base library that is taking all the information from Auditd directly rather than writing it out to a file, and that's most of the magic that we have in there. And just to give you a rough idea what that looks like is if I switch over to these dashboards, and by the way, I'm lazy. You can be lazy too. I didn't build those dashboards. Those are all pre-built. I'm just showing you what is built in here. So if I auditbeat, these are all the auditbeat dashboards that we have. And for example, there is an Auditd overview. This is the one I want. This should show me what happened in the last 24 hours. And this shows you how many events we have been collecting here. And it shows you, for example, how many connections, outbound connections we have started, how many times we bound to a socket, how many users have been logging in. And here you can see the different rules how to do that. What I haven't really shown you was the configuration. And let me give you a quick idea of what this looks like. So, like everything else nowadays, it's YAML, and you need to write a lot of YAML to make this work. Here we have the Auditd rules. So, for example, I check if somebody is trying to read passwd, then I'm logging an event that would be called developers passwd read, and then I could find the raw event. So this is for my user just developers to find that, or for example, if the admin is trying to read the home directory of a specific user, we should be able to find that with power abuse. All of those are what we have configured, and further down here, these are some of the actual rules that we use on our cloud service. So I asked to our InfoSec team, I wasn't allowed to publish all the rules that we have, but here we have a lot of the rules that we are actually using in production for our cloud service. So for example, if somebody changes the time on the system, that might be a weird signal, and we would be logging that one. And many of these. I won't go through all the different rules because there are a lot and you can just figure out what is going on your own. But this is basically what we have in here. And in 6.6, which was a while ago already, we added another way to actually collect information, but in a bit of a simpler way rather than using Auditd, because Auditd has this weird arcane syntax, and we just want to have some simple information, and that looks something like this. Down here you see, for example, I want to use our system module, and once every minute I want to check which hosts are actually collecting information, which users are there, which packages are installed, and what logins have been happening. Also, every 2 seconds, I'm checking which sockets are open and which processes are running. And rather than having the full weird Auditd syntax, you can just use these system modules and it will collect that information for you. And that, oops, that's the wrong place. If I head over to Auditbeat, and then the system overview, somewhere there is a system overview. this one here. This is then also collected by Auditd, and it shows you, for example, how many systems we are watching. For example, I'm just watching, since this is a Hello World demo, we just have one server that we're monitoring. Or how many login events, and with the Zoom level this is a bit hard to read, but we have a couple of thousand Zoom of events in the last 24 hours. And you see all of these pieces of information, like here, how many events we're collecting over time. And then you could, for example, say like, okay, I'm just interested in the logins to my server, like which users in the last 24 hours have been logging in. And then you would see, this is how many login events we had in the last 24 hours, and which users have failed to log in. So you see, people are mostly trying to brute force root, but also admin, and then Hadoop and Pi seem also to be popular. Why Pi, by the way? Yeah, Raspberry Pi, because that's the default username on a Raspberry Pi, so people just keep scanning everything for Raspberry Pis. This is not a Raspberry Pi, so you will fail, but it's just something that you will find in your logs. Or the username 123456, it's also what people are doing. And here you can see these are the ones that have been successful, for example. And you just see the actual events, how many logins you had over time, and the raw events and their success or failure. Or, for example, you could see which packages are installed on your servers, including their version. So here, you can see we have 618 packages installed. These we check every 12 hours. So here you can see, here we didn't install any new packages in the last 24 hours. But A, it's interesting to see how many packages you have. And second, you can also see in here, so this is the actual raw event. If I scroll down far enough, somewhere you can see what is the package name and also what is the version. And then you know, oh, something has a security issue. You can search over all your nodes and figure out where are your insecure packages installed, or what do you still need to patch. All of that is just here in one single place collected, and you can just figure out which packages do you have and which version, and then you can just drill down into that. And the same thing for processes and users and open sockets, etc. So you have all of those. You could, for example, also, I can quickly do that. Since I'm what am I doing here? I'm opening a socket with Netcat on port 1025. And what can you do now? You could just start talking to it. So I hope I opened all the right ports. So if you do telnet xer WTF 1025, you can just say hello. And here you will get that hello. And if you're quick enough, you can send me your own messages. Obviously, this is not really an exploit or anything, but this is a very nice demo to figure out, like, oh, somebody has opened a port, and then actually try to find that, because normally probably nobody should be opening ports here. And there are many ways to filter this down now. For example, let me show you some raw events. So here, I'll switch over from FILEBEAT to Auditbeat for those. In the last 24 hours, we had 400,000 events. And now there are many ways to filter this. Either we could look for the specific tag of a rule, or since this is full text search, we could just start searching for 1025. And you can see here we had 5 counts on that, and here we have 4 counts of this. And then you can just look at what we actually have in here. And you can see this was the command that I was running. So you see which binary has opened the port. So this is the binary. You can also see, for example, which user, this was the Ubuntu user, was doing that. So if somebody suddenly opens a port, you know which is the affected binary and what is the affected user and what do you maybe need to tie down. If you look at tags, this is just production, but if we look at the other tags, we should have a different one for the rules or for the service rules somewhere. So here you just see the specific process and what we have filtered down here. And this is actually the one I want. Tags, external accesses. Here, external access, this is the one whenever I open a socket, I log it as external access. So rather than saying 1025, because I don't know that one, you could just also say here in the search, since this is all search based, tags, and then it will suggest like these are common tags that you have tagged your events with. I could just say like external access, and then I would see like how many external accesses did we have over time. And we have a lot because we open a lot of sockets. But we have all of those logged, and then you could drill into those. Okay, so we have seen those. How are we doing timing-wise? How much time do I have left? I think we started 10 minutes late, so I probably have a little time. One thing, this demo was used by my French colleague in France yesterday. So if I hit the default port here, he had welcome to Lille, because he was doing that in France. And maybe I now break into the server and I change that message here. So for example, that should be sudo vi user www var www html index html. So he wrote welcome in Lille, and I can just write welcome in Minsk. And if I reload that, this has changed. What you might be interested in, if somebody changes something in your configuration files or on your server or a general file, when did the file change? And we have a module called file integrity for that. Let me show you the file integrity dashboard for that one. What this basically does is you configure specific folders. Every file that is in there will be hashed, and we store the hash. And every time you change a file, we will compare the hash and say, oh, I see this file suddenly has changed. And then at least you know when has a file changed. If somebody breaks into your service and starts changing configuration files, this might be a good indicator or thing to watch as well. And for example, here you can see we have moved the file. This was just now. And you can see this file was moved, and you can see the raw events down here. For example, this was me right now changing that file. And the file integrity module has changed that var www html index file, and the hash for which we use SHA-1 here has changed. And you could then figure out that, oh, something has changed here, and I want to maybe revert that or figure out why this was going on. We do support a lot of hashing algorithms. If you're kind of like concerned about performance, this here, the last one in the list, is the fastest one. Also, you can define how much scanning and hashing you want to do per minute. So you can set thresholds. A for file size. If you say files over 10 megabytes shouldn't be hashed because that might be expensive, or just hash up to 1 megabyte of files per minute and not more, not to overload your systems. So you can do those. If you run everything on Kubernetes, is anybody using Kubernetes? Okay. How do you get those auditing events on Kubernetes? Where do you run Auditbeat? Ideally on a daemon set, so it's running once per server, and then just tailing all the auditing files that you have. If you want to do that, it's a bit hidden in our repositories, but we have in beats, for example, we have deploy, Kubernetes, and then we have for FILEBEAT, AuditBeat, metricbeat. You can get the daemon set configuration, general configuration of getting those files. Also, we can add the Docker or Kubernetes metadata. So we would know this is the host, this is the pod, this is the base image where this is running on. So you could kind of figure out where stuff is happening. Also, there is the audit log from Kubernetes itself, which is kind of the same, but also kind of different, because this is just auditing what Kubernetes itself is doing, like the Kubernetes API calls. Those you can also log with this setting. For example, here you can see when your Kubernetes pod is receiving a request, your Kubernetes API server is receiving a request, then you can log that one. That will end up in a log file, and then FILEBEAT can just collect a regular log, and you can see all the calls to your Kubernetes server. And finally, just to show you what we have in here, SIEM is kind of the thing where you explore your data from a security standpoint. And the way we tie everything together in our stack is we have a naming convention of what all the different fields are, have an idea of semantic meaning of the different fields, and then can build dashboards out of those. So this app here is just for security events. So it's this one here. Give it a moment to load, and then I can show you what you have in here. So SIEM, the security information and event management. Once it finished loading and I switch over to the overview, you can see, for example, these are all the security relevant events that I have. Like flow is network flow information. We see which sockets were opened, DNS requests, TLS, Nginx access logs, system logs, and you can see the sources of where your information is coming from. On the one hand side from auditing, but we also collect a lot of information from the regular log files, or network events from PacketBeat, which is a lot like Wireshark. Who uses Wireshark? Those are normally the desperate days, right? When you don't know what you're doing anymore and you just poke at random packets. We try to kind of structure that a bit more with PacketBeat just to figure out which kind of events you have happening in here. And then in the host, you can see I have just one host, but you can see this is how many successful events for authentications you have, and this is how many failed ones you have, or how many unique IP addresses are trying to talk to your service. And then you can see this was this one host, and we could just dive just into that host. You can see where is this running, what is the base operating system, what is the instance ID on AWS where this is running, and you can dive into those authentication events or whatever users are involved in those. You can also see from a network perspective, you could see where are the requests coming from, which is kind of nice on a big map that you see this is which locations are trying to connect and what kind of events you're getting out of those. So you could see the top IP addresses or the top countries that are connecting to you and how many you have there. So for example, we could say the country with the most source IPs trying to connect to our server in the last 24 hours was unsurprisingly China, and then it's US, and then it's only Russia. And I'm almost surprised or disappointed not to see Belarus in here. Because this is a live instance. Like sometimes people try to either run a denial of service against my instance or try to brute force it. So you could do that. Finally, what can be very handy, and this is brand new, we have so-called detection rules. And the detection rule that I have here is for SSH login attempts, or sorry, as outgoing SSH attempts. So we have a lot of pre-built rules by now, like we have 92 rules of things that might be an interesting signal that something bad is going on your service. For example, the rule that I have activated here, and I can show you what this is doing, basically this is checking, does my server do outgoing SSH connections? Because this is like a live server, and maybe I SSH into the server, but it should never SSH out from that server, because nobody does that normally. And this is just a rule to alert you and tell you, hey, somebody is SSHing out from your server, and this should never happen. And then you could have an alert set on that. So it's basically looking in 5-minute intervals, it's running this query and storing the result. If you're into MITRE ATT&CK, which is like a collection of rules of what attackers might do once they got into your server and kind of like get a foothold in your infrastructure, we map those to those patterns and follow those. And you could, for example, see this was me when I logged into my server and then SSH'd out of that one. Here, you see these were the individual attempts or events, and you can do two nice things here. First, for example, here the system one is a good one. If I view that in a timeline, here in this timeline, you can see this was the specific event, and you can see all the surrounding events from it. So you can see this was SSH, this was this user, and it was an outbound request. Now I might say, I want to see what this user was generally up to, and I removed this other filter, and now I'm just getting all the events for the Ubuntu user. And then you can scroll through all the actions and things that the Ubuntu user was doing. So for example, you could see, oh, that user was using sudo. So give me all the commands where we have Ubuntu and sudo. and then you can just dive into that data and figure out what that user was up to, or talking to a specific IP address, or using a specific binary. And for the collaborative effort, you could also say like here, this one here is actually not a relevant signal. So if you have a couple of colleagues looking through the alerts that you have in your system, you could just say, okay, these were not real ones, so I'll just remove those, and then nobody else will see them. And so you can work through the alerts from your system on a collaborative basis. I think we're almost done. We've seen those. I think since we have 2 minutes left, the scaling part, something that we have built into this nowadays, and it's called Index Lifecycle Management, ILM. What this basically does is it moves your data through different phases in the lifecycle. So at first you probably have hot data. This is like what you write now and like today's data. That is what you probably will search most often. Then you might have warm data, which is yesterday to a week ago or so. Stuff that you don't write to that anymore, but you look at it more or less frequently. And then you might have this like cold storage, the cold phase. That's the snowflake. The cold phase, that is what you keep around so you can compare to the past, what has happened in the past. And you can search that. And we basically have this entire life cycle where you have different node types, and then you just keep more data in the cold life cycle because you don't do any writes and you do very few reads. So you just have more data on one node just to have different tiers of hardware, for example. And then you could say like after 100 days, for example, you want to delete the data. And that could all be built in the cluster, and it would move your data through it and just delete at a specific point in time everything and clean up. That's how you can, once you have collected all those pieces of information, that's how you can then scale it as well. These are the specific phases in there, but they are maybe a bit of an overkill. In the future, we have acquired another company that will add endpoint protection that will also basically have rules, so it will not just monitor what is going on, but it will actively block stuff happening on your nodes. So it has rules built in and says like, oh, this is weird, like you started a shell script, or you started from Outlook, you started a shell, or you from Microsoft Word, you started a shell, which is kind of a common attack pattern. And it would see those and it would block the attack automatically, and it would also report everything. So it will not only have this passive component, but it will get into the active space of that as well. And on top of everything, you have stuff like machine learning. So this is just a very simple example of what is built in. You can just activate that and it will look at the different types of events that you have and how many appeared over time. And it would then say, hey, there was an anomaly. And then you could get an alert and say like, hey, there were more security events or more access events for one specific component than I was expecting. So it basically learns what is normal for your system over time and will then let you know once something happens that was out of the ordinary. So if you have a denial of service attack or if you suddenly have more SSH brute force attempts, it would just let you know that this is not where you have been in the past. So to wrap up, I always compare this a bit to Lego. Like I said in the beginning, there is no silver bullet. There is not one thing that you do for security, but it's like a layered approach. Like you collect a lot of the pieces of information and then you need to figure out what is normal in your system, what is not normal. What do you actually need to investigate? And all of those are pieces you can put together. And Auditd, Auditbeat, how to scale it, how to integrate it with Kubernetes, etc. All those are different pieces you kind of need to put together to have the full picture, but only then will you have a good overview of what is happening in your systems. If you want to try all of that out, it's including the rules. It's in the GitHub repository there, which basically spins up this instance and applies the rules, and you can just start poking around in it. So that's that. And with that, if you want to have or look at similar projects, Slack has built something similar because they had kind of a similar problem that they didn't want to write out auditing events to files and then parse them back. And that generates, I think, JSON. And there is one, the our shape at the bottom. If you want to get auditing events in XML, that one can generate auditing events in XML. But it can also do JSON. But the XML is kind of the not so common one. But these are kind of similar projects to what we do with Auditbeat to kind of get to more structured events around auditing. Cool. Any questions? If you want the slides, this is the link to the slides. any questions? Because I think I need to pick the best question at the end.
Hey guys, feel free please. You have a chance to win this beautiful gift from Wargaming. Oh, okay.
Hi. So I have two questions. First of all, first question, the main question, is it for free?
Yes, everything that I've shown is for free.
And second question, can I use it with open distro?
That will be tough because the way, so it depends a bit on the feature, but for example, you will not be able to combine SIEM with OpenDistro because you cannot, on the where SIEM is included, into that binary you will not be able to install OpenDistro because it clashes on registering some namespaces. Sure.
Hi, thank you for your information. Can you tell us something about performance of Auditd in the work, in the workload with hashing of files in our systems?
I mean, first off, for the file integrity, you don't have to use that if you are afraid of it. But here in the configuration, for example, you see you can limit the scan rate and you can also limit how big files should be scanned. And then you can change the hashing algorithm. So these are kind of the performance knobs you have around that one. I didn't write many files here. You won't see much there, but that's the wrong window. Let me show you how much, or let's check how much of the system resources Auditd is actually using on my system. Since I'm monitoring my entire instance, we can just check easily. Because when I get to the right dashboards, go to the right dashboards, then I can just say system. And there is from metric-beat system overview, that should be the right one. And that is the general overview, and then I can click into this specific one. And let's say in the last 24 hours to see what that was up to performance-wise. You can then see how many processes have been running, how much CPU and memory are you using, and further down, so here you can see the CPU usage and the load and the memory usage over time, and down here we can actually see the resource usage. So for example, you can see, okay, this used 5% of the memory. I think this is a 1 gigabyte instance, so this is 5% of 1 gigabyte, and then you can see that it used 1.03 whatever percent of my CPU. Obviously this will depend on how much load you have and how extensive your rules are. So for example, in terms of rules that we are collecting here, bless you, there are quite a few, but you will need to measure that on your hardware with your rules, and for the specific load of your system, what does it actually mean. But in general it should be pretty light, and with metric-beat you can also just keep track of that and see how much you're doing that.
Okay, thanks.
That's all? Oh, okay. Let's choose.
I'll go for the second question.
Oh, okay. Come here. Oh, guys, come on. Yeah. And one gift for you.
Thank you very much. I hope you all have still power for the beer afterwards. You feel very tired.
Thank you for your great presentation.
If you have more questions, find me afterwards, ask me. If you want stickers, we have a lot of stickers here. Thanks a lot.